Okay, this lecture is going to be on Coulomb's law, and Paul Abdul can introduce this better than I can.
We come together as opposites attract together. It ain't fiction, the natural fact. We come together as opposites attract.
Okay, so the goals for this presentation are you should understand the attractive and repulsive nature of the electric force, and you should be able to compare it to the gravitational force. You should also be able to graphically and algebraically demonstrate the different variables on the electric force, the effect of different variables on the electric force, and you should be able to calculate for a missing variable using Coulomb's law. So the fundamental law of static electricity, which is what Paul Abdul enlightened us with, is the fact that opposites attract and like charges repel. So if you have a positive and a negative, the positive and the negative will attract. If you have two positives, they will repel. If you have neutral objects, they actually won't do anything. But if you have one neutral and one charged object, they will attract because of polarization. Now, it's very important that the fundamental law of static electricity tells you the direction of the force only. It does not tell you the magnitude. In order for you to figure out the magnitude of the force, you have to use what's called Coulomb's law. And that's what you see here. You see Fe, which stands for the electrostatic force, is equal to kq1 q2 over r squared. Sometimes this is represented as a d, sometimes it's represented as an r. It's the same thing. Any sort of negative value that you get, all it does is indicate that it is an attractive force. If you get a positive value, it indicates that it is a repulsive force. So now let's take a look at these individual things. Now, this is the electrostatic force, so obviously it's measured in newtons, because all forces are measured in newtons. It is the cause of all the contact forces that we've talked about so far, this electrostatic force. This K term is the Coulomb's constant. It has a value of 8.99 times 10 to the ninth, and because of that, it shows you that it is much, much, much stronger than gravity. Remember, the constant value for universal gravitation was like 6.67 times 10 to the negative 11. So it was a decimal, a whole bunch of zeros, and then the number. Whereas this one is 8,990,000. I mean, it's a huge number. Q1 stands for the charge of the first object. Q2 stands for the charge of the second object. Remember, both of these have to be measured in coulombs. So if you see something in millicoulombs or microcoulombs or something like that, you need to convert it to coulombs. And finally, you have R, which is really just the distance. Sometimes it's called the radius just because a lot of times we tend to deal with things that move in a circle with this. But it's the radius of the distance between them. Now notice that this is a squared term. Any distance, radius, whatever, needs to be in meters, remember. So this is Coulomb's law, and you will be using it quite a bit. Now there are applications of Coulomb's law, including electroplating. You can put gold on top of another metal to make it appear more valuable than it is, or to use a cheaper metal and then actually use the gold as a contact like they do with HDMI cords. In addition to that, these electronic signature pads. If you have an electronic signature pad, what it does is it uses the electrical difference between the pen and the pad to actually pull up these capsules, which give the appearance of ink. And then also, it is what the normal force is. The normal force is from the electrostatic force, as well as all other contact forces. So Coulomb's law is actually very, very, very important when we start to talk about really anything to do with electricity. So you should be able to understand the attractive and repulsive nature of the electric forces, and you should be able to compare it to gravity and say that gravity is much, much weaker than the electric force. You should be able to graphically and algebraically demonstrate the effect of the various variables on the electric force. So you should be able to take the equation and turn it into a graph for Q1 versus F, or Q2 versus F, or R versus F. You should be able to do that with relative ease. And you should be able to calculate any of the unknown variables. So you should be able to calculate for force, charge, radius, given all the others.